9.1, question 12. The graph shows the perimeter of a square in relation to the length of its side. So here's our graph, and it says side length in centimeters. And it goes in increments of 1, 2, 3, 4, 5 centimeters, and it's labeled S. So this line, the x-axis is labeled S for side length. And our y-axis is increments of 2, and it represents the perimeter of the square, because we see here the perimeter of squares. So this is the perimeter of the square in centimeters. And it goes up by 2 centimeters, 4 centimeters, 6 centimeters, etc. So it says, copy and complete, and copy the table and fill in the missing values for S, which of course we know back down here is the side length, and P, which we actually have labeled here as perimeter in centimeters. So we actually labeled again up here. So if the side length of a square is 0, well, guess what? The perimeter is 0 as well. If the side length of a square is 1, well, that would look like, let's just go draw that real quick. Side length of a square. Here's my beautiful square. Side length is 1. Then the perimeter, and I'll even use a different color to wow you with my technical skills here. Then the perimeter, the distance around from here, 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 and here around the square is going to be 4. Because 1 centimeter, 2 centimeters, 3 centimeters, that's the perimeter, is the distance around a shape. Now what if, instead of being 1, the side length was 2? What would the area, or the perimeter, excuse me, of that square be? Well, we can 2, 4, 6, 8. It's actually 8 centimeters. Now, how do we get that? Well, there is a formula we can use, and that's the perimeter of a square is equal to 4 times the side length. That's the formula. If you take a side length of a square and multiply it by 4, that will tell you the perimeter of the square. So here, if we use this formula, it's probably a lot easier since we're studying algebra, how we can get that. So here I have my S and my P. I know my P, so I can substitute it into my formula. So 12, instead of saying perimeter, we can say 12 because it's given to us right here, equals 4 times the side length. Now we have a simple algebraic equation with 4s equals 12. I know from algebra this is my coefficient. So if I divide both sides by 4, I get 3 over here, and I get s over here. So the side length is 3. And I can put that in, and actually it fits quite nice in here. 0, 1, 2, 3, 4, 5. Makes a lot of sense. It does look like it fits. Using this formula again, let's just erase this stuff here. Erase all this goodness here, and then I'll start again. We'll use the same formula again for question, for this one right here. So I know my side length this time, it's 4. So if I know my side length, I don't know my perimeter. So perimeter equals 4 times, instead of side length, I know it, it's 4. So 4 times 4. What is the perimeter of a square that has a side length of 4? Well, the perimeter is 16. So we put 16 in here. And 5, we can just substitute this again. I'm too lazy to write it again. Put 5 in there instead, because now the side length is 5, so S is 5. 4 times 5, the perimeter would be 20. So I'll put 20 in here. And then it actually skips a whole bunch, because we see that 0, 4, 8, 12, 16, 20, it goes to 32. So this is not 6. Some people might be fooled into thinking, well, I see 0, 1, 2, 3, 4, 5. This must be 6. Haha, you're not fooling me, but you'd be wrong, because here's 28. So it stops becoming sequential right here. So we really need our formula here. So the perimeter of a circle equals 4s. I'll write that down again. And now we know the perimeter is being 32. So 32 equals 4s. I'll divide both sides by my coefficient again. I get 8 over here, and I get s over here. The side length, if the perimeter is 32, the side length is 8. I'll erase it because I'm running out of space. So I'll erase all this again. Use the same formula. This time I know my side length, it's 28. So the perimeter of this square has 4 sides of 28 centimeters each. 4 times 28, well 4 times 20 is 80. 4 times 8 is 32. 80 plus 32 is 112, so 4 times 28 is 112, and the perimeter is 112 centimeters. And the last one, thank God. The perimeter we know is 124. So 124 equals 4 times s. Divide both sides by 4. S equals, well, what's 20? 120. Well, 12 divided by 4 is 3. So 120 divided by 4 is 30. 4 divided by 4 is 1. So 30 and 1 is 31 centimeters. That was exciting. Describe the patterns in the graph. Well, we already did that. We filled in the chart. Patterns are for every centimeter in side length, the perimeter is 4 times its great, and we know that just from basic logic. Are there any other points possible between those shown on the graph? Well, the answer is yes. Is it possible to have a side length instead of being 2, is it possible to have a side length of 2.5 centimeters? Of course it is, and that would have went right in here. If we had it, we could have plopped it in right between 2 and 3, 2.5, and the perimeter would have been 4 times that. So, well, 2 times that is 5, so 4 times that is 10. So the perimeter of this particular square would have been 10 centimeters. So yes, it's possible. And does the graph represent a linear relation? It certainly does, because if I was to take my little arrow here and connect all the dots, every dot that meets the requirements of this particular one does fit on that line and therefore is a linear relation.